Let's be real. Have you ever stared at a spreadsheet just packed with numbers and it all just blurs together? You know there's a story hidden in there somewhere, but it's impossible to see. Well, guess what? There's an amazing tool that can turn that numerical chaos into a picture that makes perfect sense. Okay, brace yourself. Look at this. These numbers are the heights of 100 semi-pro soccer players, measured in inches. Just by glancing at this, can you tell me the most common height? Or what the average is? It's tough, right? It's just a wall of data. Raw numbers like this are pretty much useless on their own.
So the big question is, how do we get from that confusing jumble to some actual insight? What is the story these numbers are trying to tell us about these soccer players? To find out, we have to give our data a voice and, more importantly, a shape.
And that's where our hero comes in. The solution is an elegant and surprisingly simple chart called a histogram. It's literally designed to take a huge pile of data and make it easy to understand in a single glance.
So, what is a histogram really? At its heart, it's kind of like a bar chart, but with a very specific, very important job. As the OpenStack statistics text points out, it's the perfect tool for when you have a big data set, like 100 values or more, just like our soccer player data. Its whole purpose is to show you three key things instantly: the overall shape of your data, where the middle is, and how spread out everything is.
All right, let's pop the hood and see what makes this thing tick. Along the bottom, you've got your horizontal axis. That's where our data values go, so in this case, the player's heights. Then, going up the side is the vertical axis, which shows the frequency, a fancy word for how many. And then you have the bars themselves, which we call bins. The best way to think of it is like a city skyline. The taller a building is, the more data or people are packed into that one block.
Okay, enough theory. Let's get our hands dirty, right? We're going to actually walk through how to build one of these things, step by step, using our soccer player data. We're about to turn that ugly wall of numbers into a really clear picture.
And it's not as complicated as you might think. It's really just a 5-step process. First, you decide how many bars you want. Then you find the range of your data from the smallest number to the biggest. After that, you figure out how wide each bar should be. Then the big job. You group all your data into those bars. And finally, you just draw the chart. See? Totally logical.
All right, let's apply this to our soccer data. The shortest player we have is 60 inches tall, and the tallest is 74. Now you might be asking, how many bars should I use? And honestly, there's no single magic number, but a good rule of thumb is somewhere between 5 and 15. For our data, 8 bars feels just right. It'll give us a good amount of detail.
Okay, next up, figuring out how wide to make each bar. We take our full range and divide it by the number of bars we just picked. Now, our source material does a neat little trick here. It adds a tiny bit of buffer to the range, making it 14.1. When we divide that by our 8 bars, we get 1.76. But here's the really clever part. We round that number up to 2. Why? Well, it just makes the chart cleaner, and it's a pro move to make sure no data point ever falls exactly on a dividing line. So after we group all 100 player heights into our 8 bars, each 2 inches wide, we get this. And wow, right? This shows you the power of a histogram. We've gone from a totally unreadable list to a crystal clear chart. You can immediately see the story. Most of the players are clustered between 66 and 70 inches tall. That's the insight that was hiding in plain sight. But you know, just making the histogram, that's only half the story. The real magic, the real insight, comes from learning how to read its shape. The overall form of those bars tells you a deep, deep story about your dataset.
And our source material really hits the nail on the head with this. Those 3 things, shape, center, and spread, are the treasures we're looking for. The shape is the first thing you'll notice, and it tends to fall into a few common, recognizable patterns.
You've probably seen this one before, right? It's the classic bell shape, what statisticians call a normal distribution. You see this pattern everywhere in the world. It's got that single peak right in the middle, and the data just tapers off evenly on both sides. A lot of human traits, like height or IQ scores, tend to look just like this.
But what happens when things aren't so perfectly symmetrical? Well, that's when you get what's called a skewed distribution. If the long tail of the data stretches out to the left, we call it left skewed. Think about grades on an easy test. Most people do really well, but a few do poorly, creating that tail. And if the tail goes to the right, it's right skewed. The perfect example is income. Most of us are in one area, with a few outliers making way, way more.
And it doesn't stop there. You'll run into a few other common shapes out in the wild. Bimodal means you have two peaks, which could be a hint that you're actually looking at two different groups mashed together. Uniform looks like a flat rectangle. Think about rolling a die 1,000 times. And sometimes, well, the data's just random noise with no real pattern to speak of.
Okay, this brings us to our final section, and honestly, this might be the most important part of our whole chat. Histograms are incredible tools for truth, but like any tool, they can be twisted to mislead you. We're going to learn how to spot a deceptive chart so you can become a smarter consumer of data.
So first, let's look at what an honest-to-goodness histogram is supposed to look like. The number one rule, every single bar must have the exact same width. This is absolutely non-negotiable. It guarantees you're making a fair apples-to-apples comparison. The only thing that should change is the height.
All right, now look closely at this one. Something's off. It might look okay at first glance, but there's a sneaky little trick being played here. Do you see it? Pay really close attention to the bottom of the chart.
Did you spot it? The lie is in the bar widths. Some are way wider than others. And this is a huge problem because our brains don't just see the height of the bar, we see its total area. By making a bar wider, a sneaky chart maker can make that category look way more important than it really is. It's a classic and very effective way to lie with statistics.
So what's the big takeaway here? Why does this even matter? Because you are swimming in a sea of charts and graphs every single day, and all of them are trying to persuade you of something. But now you know the rules. You can protect yourself. You're not just a passive viewer anymore. You're a critical thinker who knows how to question not just the data, but how it's being shown to you. So, from now on, when a chart pops up in a news story or a presentation at work, you'll be ready. You'll know to check the axes, to check those bar widths, and to ask yourself, is this chart telling me an honest story, or is it trying to sell me one? So I'll leave you with this. Will you ever trust a chart blindly again?